Hi, Arthur, and today I'll be presenting on thermophysics concept in transfer. Heat is a form of energy and it flows from a hotter region to a cooler region until both regions are of thermal equilibrium. Temperature tells us how hot or how cold something is. It measures the average speed of particles in a substance. Faster particles equals to higher temperature. There are three ways heat can travel: radiation, convection, and conduction. As you can see from the video, radiation takes place as the fire emits infrared radiation that travels in straight lines and warms objects and people nearby. Convection also takes place here as hot air rises from the fire, creating convection currents that warm the room. Conduction takes place as heat spreads along the length of the rod through conduction. When heat or energy from a heat source is transferred through a material without the movement of material itself. Now I'll be showing you how conduction occurs from the heat source to the frying pan and to the butter itself. See, the butter melts as heat from the heat source is transferred to the frying pan through conduction and to the butter and thus melting it. This is the principle of convection, the cool and air conditioned room. As you can see, cool air from the air conditioner is released from the top. The cool air enters here and sinks to the bottom. As it sinks to the bottom, it will push the warm air up, and since warmer air rises lighter, it will rise up to the ceiling. This creates a loop, cool air sinks and warm air rises. The air continuously moves in a circular pattern, spreading coolness throughout the room. Heat from the sun travels through radiation to Earth. Unlike convection or conduction, radiation does not need a medium to travel through, not even air. Heat energy from the sun is converted into electrical energy by these solar panels right here. This solar panel meter reads how much kilowatts of energy is produced. Now I'll be explaining conduction, convection, and radiation in an experiment. Our objective is to observe how alcohol liquid expands when placed in warm water and contracts when cooled, mimicking how a thermometer works. You'll need these materials. Step 1. Fill the bottle with about 1/3 halfway with alcohol and water of equal amount. Next, add a few drops of food coloring and mix well. Next, insert the straw and position it so it hangs into the bottle with the bottom end submerged in liquid but not touching the bottom or the bottle's base. Ensure most of the straw sticks out of the bottle. Next, observe the fluid level in the straw at room temperature. Use a thermometer to measure the actual room temperature. Mark this level of the straw and the bottle with the room temperature using a permanent marker. Next, we are going to be testing our thermometer in warm water and cold water. First, place the bottle in a container of warm water. Watch the liquid and the straw rise as the liquid expands. Once stable, mark the new level at the bottle and label it with the water's temperature of 40 degrees. In the first picture, you can see the thing at the room temperature, and in the second picture, you can see it at 40 degrees Celsius. These are my markings. First, here at 40 degrees Celsius, and here at 28 degrees Celsius. The thermophysics principle behind a home thermometer is thermal expansion, the idea that materials expand when heated and contract when cooled. This change is used to measure temperature. Most traditional home temperature thermometers rely on the predictable behavior of materials when they are heated. The thermometer absorbs heat from its surrounding until it reaches thermal equilibrium. When a substance is warmed, its particles move faster and spread out. This causes the liquid to expand and rise in a thin tube. As the liquid drops, the liquid contracts and falls. Thank you for your kind attention.